Testing, testing, testing. Well, this is chapter 4 for C++ on page 105. I've highlighted some of my narrative in yellow, so I apologize. It may not read for you well, but in your chapter, you can follow along on chapter 5, in chapter 4 on page 105. So we're defining an algorithm as a procedure for solving a problem in terms of the actions to execute in the order in which these actions execute. So pseudocode is an informal language that helps you develop algorithms without having to worry about the strict details of C++, or Java, or Visual Studio, or Python. Pseudocode is a generic, informal way of developing your logic, your actions or tasks that you want the program to execute, and the exact order in which they are to execute. So it's not quite code, and it's not quite an algorithm. It is a listing in a pseudo informal language, but it is definitely not going to execute on a computer by itself. Now, pseudocode is helpful because it helps us think out or place our logic and develop our logic for a computer program. And it's a way to communicate between programmers and non-programmers. So in your programming teams, others who are not necessarily programmers can read and interpret and follow the logic and the actions of your code. Now, you may have seen in chapter 2 and 3, I did provide pseudocode as a link within those modules. And now for chapter 4, I provided pseudocode for your Prog 4 assignment, your exercise 4-13. And you can see that I'm writing this out in English. I'm using some of the documentation scripting for C++. I'm giving identification of the type and a variable name, the type and the variable names. I'm indicating that I'm going to use a while driver, which you will learn about in this chapter. I'm using some cout directives, just enough to kind of document what tasks need to be done. I'm indicating I have a body of code that needs to be executed, and then of course my body of my main has to end. And prompt the user. Well, there we're going to have to use some output directives to prompt a user. If we want to collect data, we need to input some data. We need to accumulate and calculate. And just here we're using an if statement with a body of block and then final calculations. We're going to prompt the user again. So this pseudocode is almost C++, but not quite. It's in a narrative enough in English that your co-workers who are not programmers can understand and interpret the process, the logic, the actions in their order in your code. Next, we look at control structures, and in this book, they say control statements. Use control statements as a synonym. In chapter 2 and 3, we pretty much were using sequential processing. That is, we processed one line of code after the next line of code as they were presented in the source code itself. The research in the 1960s of Jacoponi and Bond had demonstrated that programs could be written without any go-to statements, which was termed structured programming. Very interesting reading. And since then, all computer programs can be written with only 3 control structures: simple sequence, selection structure, and the iteration structure. So our simple sequence UML design is we're coming into a statement, we move through that statement, we move to the next statement, and the next, and the next, and we continue sequentially. Simple sequence, sequential, control structure, sequence statements. Next, we have our selection statements on the top of page 108. And C++ has 3 types of selection statements: the if statement, the if else, and the switch statement. The if statement performs the body of the loop if the condition tests true, otherwise it skips the body of the loop. The if else, if the condition is true, we process the body of the loop. If the condition of the if is false, we process the body of the else loop. And the switch statement allows us to select between many different actions, and that multi-selection statement of the switch we will look at in chapter 5. Iteration statements. Iteration might be a new word for you. Iteration, sometimes called repetition. You may have heard of looping. They're synonymous. Iteration, repetition, a looping. And as long as the condition of your loop remains true, we continue to execute the body of the loop. That is, we work within the braces. If the iteration loop tests false, we stop and move immediately to the next statement following the closing brace. Our iteration statements begin with while, do while, for, or range-based for statements. And again, we continue in chapter 5 with the presentation of several more of these iteration statements. So, introducing additional keywords, if, else, switch, while, do, and for are C++ keywords. A keyword list is on bottom of page 108, and keywords can only be used as their keyword purpose, not for any other syntax in C++ source code. So our summary, just a reminder that in this book now, from this point forward, it refers to control statements rather than control structures. So we have the sequence statement, the selection statements, and the iteration statements. Our single if statement in pseudocode, if a student's grade is greater than or equal to 60, print passed. Well, translating that to C++ code obviously is different than translating that pseudocode to Java or Python. We have to follow the syntactic rules of the language at hand. In C++, we write if the condition in parentheses, student grade is greater than or equal to 60, our open brace, and the processing of the true path, which in this case is just to see out the word passed, and close brace. You've experienced the single if statement in chapter 2 and 3. In addition, we have a keyword bool, which C++ provides as a data type. It's a Boolean variable data type that can hold only the values of true and false. So we could test expressions. If they evaluate to 0, it's treated as false. If the expression would evaluate to anything other than 0, it's treated as true. Our UML then for an if single selection statement, we are moving through the program into a diamond for calling a question. And to the right, if grade is greater than or equal to 60, we're going to print passed and then follow and connect back to the spine of the flow of our logic. If we call a test and it tests false, we simply continue to the next statement. The if-else double selection statement, our pseudocode might read, if student's grade is greater than or equal to 60, print passed, else print failed. Well, in C++, we could write this source code as, if the condition, grade is greater than or equal to 60, the true block with its open and closed brace, we're going to print passed. Else, if the condition, grade is greater than or equal to 60 is false, we'll follow the else block. We see the open and closed brace of the else block and print failed. Looking at our pseudocode, or I'm sorry, our UML for the if-else double selection statement, we're coming into our if-else with a question. If grade is greater than or equal to 60, and we typically have the true condition flow to the right. and then we process the body of the loop. There could be multiple statements in the body of the loop. We're going to print past and then connect back to the main spine of the program logic. If our question grade is greater than or equal to 60 is false, we go to the left and print failed and continue with any other statements that might be built within the false block with the beginning and ending brace. Now our nested if-else code looks like page 112. It's an if-else, 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 and then notice your trailing matching bracing. And as we continue to indent, which we should, we're moving to the right, and oftentimes in our editors, that might and does cause word wrap, which logically doesn't help us in reading the code. So a preferred way is to nest our if-elses by writing our code in this method. If student grade is greater than or equal to 90, open, close, brace, do the true path. Else if student grade is greater than or equal to 80, then the true path for that condition. Else if student grade is greater than or equal to 70, bracing for the true path. Else, the false, if student grade is greater than or equal to 60, process your true path. Else, cout equals F. Now, if student grade is greater than or equal to 90, we're going to process the true path, and we're done. There's no else path to follow because we followed the first true path. Else if student grade is greater than or equal to 80, print out B. We followed the else path. There's no other path to follow, so we exit. And the dangling else problem is when we have mismatched or forget bracing. And so it's very important when you're designing your nested ifs that you have your corresponding bracing. The next example of code just indicates that we have an if-else selection statement. If grade is greater than or equal to 60, print past, beginning close for the true path. Else, print cout failed, and then cout you must take this course again. And we're just demonstrating that in the block of the if or in the block of the else, we can have multiple statements. On page 114, just be aware of the conditional operator, the question colon. C++ provides an operational conditional operator. It's the question mark colon. It's oftentimes substituted for the if-else. It makes your code shorter and clearer, always our goal. And there's actually 3 parts, so we call this our ternary operator. Cout, student grade is greater than or equal to 60. We're calling a question, so there's our condition, and we have the question mark. Is student grade greater than or equal to 60? If it is, we do the true path, whatever happens to be following the question mark but before the colon. If our condition tests false, we do whatever follows the colon as a false path. So now we can see that code example. Grade greater than or equal to 60, question mark, so that's our condition. Is grade greater than or equal to 60? If it is, we do the true path, cout, past. If it's false, we do the false path, which follows the colon. Ternary conditional operator. Ternary, right here, Ternary. Well, now we're going to develop our student class using nested if-else statements on page 115. Our student class object is going to be instantiated. The class contains data members of name, type string. It's going to store the student's name, and a data member named average of type int to store the student's average. The constructor of our student class initializes name and average. Member functions include set name and get name, and we're getting familiar with those methods, and they're going to manipulate the student name. Member functions set average and get average. We're pretty familiar with set and get. And the member function of get letter grade, which uses nested if-else statements to determine the student's letter grade based on the student's average. Now remember that each student object knows its own data members. So each student object will know its name and its own average. Each student object that you instantiate will know its own student's name and its own student's average. So please read through the narrative that dissects the code, and we'll begin to work through this code together. In review, we have control structures, and in this book called control statements of simple sequence, selection, and iteration. Sequence is simply the order in which our statements were written, one after another. Selection allows us to select. We have the single if true, then process the body of the loop, otherwise continue with the next statement. If else allows us to continue to process the true path if the condition is true, or process the false path, else process the false path if the condition tests false. Switch we're going to study in chapter 5, and then we introduce the operational conditional operator of question mark colon. Iteration, we have the while do, for, and range-based fors, and we'll continue with their dissection in our next lecture. So on figure 4.6, which is a student data file shared with you, you can print your source code or read from the textbook on page 115 through 116. This is defining our student class object. So I have my class student begin and end. Remember that our .h files must end with the semicolon. In my student class, I'm going to go down and look at the private data first, so I can look at the data members of this object. I have a string identifier name, and I have an integer identifier average, and I'm going to go ahead and initialize each instantiated student object of average to 0. So I have with my student class header the class object name. My data members are private, name of type string, and average of type string. And I just made a note here that I am going to initialize average to 0 for each instantiated student object. Continuing with the code as I'm dissecting the code of the student.h header file. My constructor begins with student paren. Uppercase has to match the name of the class. I'm going to pass a student name as a string to the constructor, and I'm going to pass an integer, and it'll be assigned to student average. So I have my constructor in the bottom compartment of my UML model. Constructor, lesson, constructor, greater than, student, again, must match the name of the object. I have a student name of type string and a student average of type int. My next data function is to set name. Set name is expecting that a string is going to be passed to it from our driver program, from the driver student test.cpp, and that student name will be assigned to name, the data member for this object. So I have set name. It expects a student name to be assigned by passing its value as a get name. We're getting more familiar with these member functions now. Get name is going to return a single, so we use constant name, the value of name for this object as a string. So we have get name, no parameters are sent to it, but it returns as a string a value. Next we have a member function set average. Set average expects an integer to be passed to this method. So we'll be passing the student average to this method and it will continue to process. So we have the set average method. Student average is going to be assigned a passed integer from the driver program. Get average. Remember that every object knows its own data values. So each object is going to know its own average. So we're going to get the average as a single value returned as an integer to the calling environment. And then we have a get letter grade. Get letter grade is a member function. It's going to return a string. So here's our get letter grade. No parameters are sent to it. We're going to return a single value as a string. And we're setting up a local string by the name of letter grade. We call this a local identifier, a local variable. It's known only within the braces, open and close, of this body of code, which is the get letter grade method. So it's only maintained for the duration of this method. Now, if average, well, average is a data member. So get letter grade can make use of this object's data member name and data member average. So we're comparing if average is greater than or equal to 90, here's the begin end for that if it's true. If it's false, else. If average is greater than or equal to 80. If the condition is true, we'll do the true block and exit. Else, if it's false, we'll do if average is greater than or equal to 70. True block. Else, if that's false, we'll test if average is greater than or equal to 60. If that's true, we'll do the true block. Else, if it's false, we'll do letter grade is assigned F. And then we return that letter grade to the calling environment. So our main driver program is going to instantiate class objects. We just want to remember that objects, remember they're data members throughout their lifetime. So for as long as they're in existence in current memory, they can always return their data members value. So this is my student test. I'm testing my student.h class object. This is my source code as a driver program. Be sure to include your student.h header with the quotation marks. And we can use naming or namespace as a directive in our source code, not in our header files. Here's a int main, the main starting area of our program with a begin and an end block. I'm going to instantiate a new student object by the name of account1. So I have account1 named, and I'm going to pass a string value and an integer value. So here's my constructor. I'm going to construct a new student object by the name of account1 with a student name and a student average assigned. Jane Green and 93. Name is immediately assigned Jane Green, so Jane Green is now assigned. And in account1, we want to just make sure that we set the average as it's a valid average. So set average, and I'm going to pass an integer value, which right now is the 93 int value that I passed from the calling environment. So set average, I'm calling the set average method, passing it 93. Student average is equal to 93, and I'm going to validate that that's within our average range. If 93 is greater than 0, it is, so I'm going to process the true path. If 93 is less than or equal to 100, it is. So average now is set equal to student average. So account 1 dot average is set to 93. It had been initialized to 0. It's now overwritten to 93. Back to our main driver, the next statement is create, instantiate a new student class object named account2 and pass a string John Blue and an integer. So my constructor says, okay, we're going to instantiate a new student account. John Blue has been passed as a string to student name, and student average has been assigned 72 as an integer. Name field in account2 account2.name has been assigned to the string John Blue. But before we assign average, we want to make sure that we do some validity testing. We're going to set average sending 72. Our set average method receives 72 in student average as an integer. If student average 72 is greater than 0, it is. So I'm going to process the true path. If student average is less than or equal to 100, it is. So I'm going to process the true path. 72 is assigned to average. Student average is equal to 72. It's assigned to average. So now 0 is overwritten with 72 as an agreeable, valid student average for account 2. Back to the main program driver. I have 2 accounts, class accounts established in current memory. Account 1 as a student object and account 2 as a student object. Now I'm going to account1.getName. I'm calling the getName method, and it's going to return name, which is Jane Green. Jane Green's letter grade equivalent of, remember this trailing space is quoted to the screen, account1.getAverage. So account1.getAverage. GetAverage is going to return a single constant value of type int, and it's going to return account1.average. Account1.average is 93. So sure enough, our first line of output on page 117, Jane Green's letter grade equivalent of space 93 space is colon A. So how did I get that A to print? In the driver program, I have account1.getName equivalent grade of get average was 93 is with a colon and a space account.getLetterGrade. So account1. So with account1 in hand, I'm going to call the member function getLetterGrade. It's going to return one value of type string. String letter grade is a local identifier. If average, well, the average for account 1 is 93. So if average is greater than 93, it is, so I'm going to process the true path. Letter grade is assigned the string value of A. I process the true path, so there's nothing more to process. I'm going to return letter grade of letter grade A. And my first output line of text is complete with the letter grade of A returned and output. We continue with the next line of text in the student test.cpp, and we're going to work with account 2 and getName and output it. So getName, I'm going to return a constant of type string. I'm going to return name, and account2.name is John Blue. So I'm returning John Blue. Get name, John Blues, apostrophe S is quoted, letter grade equivalent of with a space. Now I need to get a count to get average. So get average. Account to dot get average method is going to return a constant integer. It's going to return average. And account to knows its own average is 72. So that will be printed. So 72 space is colon is, and now we want account to get letter grade. So with account to, I'm going to get the method letter grade. It returns a single constant value of type string. I'm reinitializing the local string letter grade, so it's now nothing. And with account to's average of 72, if average is greater than or equal to 90, it's not. So I'm going to do the false path, else. If 72 is greater than or equal to 80, it is not. So I'm going to do the false else path. If average is greater than or equal to 70, it is. So I'm going to process the true path, begin end, letter grade is assigned a C. And exit your if else nested and return letter grade as a string. So I'm going to return a C, and we've finalized the output of the final line for our program. John Blue's letter grade equivalent of space 72 space is colon space a C. So here with these figure source codes, please spend time reading the narrative associated with the C++ syntax, and we will be continuing then with chapter 4's lecture in our next recording.